Welcome to IBLE Math, where we teach math for students, by students. In today's video, we will do a quick overview of what arithmetic sequences are. Now, arithmetic sequences are one of the first topics of the IB Math AA, HL, and SL syllabus. Now, an arithmetic sequence are those kind of sequences that have always a common jump in between terms. Now, what do I mean by this? If we take a look at this combination of numbers, this sequence of numbers, we can see how in between each term, in between the first and the second term, and in between the second and the third and the fourth and the fifth, there's always a jump of +2. Now, this is a sequence, and there's always a common difference. That's how we call it, a common difference in between them. In this case, it will be a common difference of +2. So that this is an example of an arithmetic sequence. Now, there's a common or a general equation or formula for arithmetic sequences, and it's written here. Now, arithmetic sequences, or the general formula for an arithmetic sequence, states that un, which is the nth term, so in case we wanted to find, the third term of a sequence, and here notice how the third term is, 1, 2, this is our third term. So the nth term of a sequence, we can replace this n by the number we want to find, so by the position of the term we want to find. The nth term will always be equal to a, which is nothing else but the first term of the sequence, which can also be labeled as u1. In this case, again, this would be this would be 1. This would be our first term of the sequence, because it starts by 1 and then it starts adding 2 every time there's a jump. And then this is a plus n minus 1. Now, n is, again, the number of terms that we're looking for, or more specifically, the position of the term we are looking for. So in case we want to find the third term, we would substitute that n by a 3. Then there's this minus 1, and all of this is multiplied by d, which is what we explained before, which is the common difference. In this case, it would be 2. So if we take a look at our first example, this is one of the most basic exercises and one of the first things you'll find in the chapter. They can ask you something like this. What would the 21st term of this sequence be? So again, you can see how the question is written down here, and you've got this sequence here. What would the 21st term be? Now, you could obviously start to write, well, this is our first number, second, and so on. And so you could start to write 11, 13, because we're just making a jump of 2. And we could do this until reaching 21 terms. But it really doesn't make sense, because we've got an equation that calculates it faster for us. So if we want to find u21, so the 21st term, that would be equal to a. Again, we're referring to this equation. So we're simply going to substitute the values. And so we would get a, or u1, which again in this case is 1, because this is the first term of our sequence. It doesn't need to be 1. It doesn't need to be any specific number. It can be any number. But in this case, it's simple. It's simply 1. So it would be 1 plus n minus 1. So n would be 21, because that's the position of the term we were looking for, minus 1 times the difference, which is 2. We have said before that there's always a jump of 2 in between numbers. From 1 to 3, the difference is 2. From 3 to 5, the difference is 2, and so on and so on. So we would see that u21 equals 1 plus, this is going to be 20 times 2. And so u21, so the 21st term, which is what they are asking us to calculate, will be equal to 41. And this is our final result for this first exercise. Now, there are other common exercises that can be asked. Exercise 2 says, a sequence with a common difference of 7 has 31 as the fifth term. What is the first term of the sequence? Now, okay, we don't know what a is, but we know all the other values. So we simply have to refer to this equation. We simply have to, look at this equation and see what can be calculated. Now we know that u5, so the fifth term, they told us is equal to 31. We know that the common difference, so d, is going to be equal to 7. And we want to calculate a, which is our first term of the sequence. And so we can just write the equation. So 31 will be equal to a plus n minus 1. Again, it's simply substituting values from this equation. So a plus n minus 1. Now n, we know that n is going to be equal to 5, because that's what we know. So this is going to be 5 minus 1 times the common difference, which is 7. And so 31 will equal to a plus 4 times 7. And this is a very simple equation. 31 minus 28 will be equal to a. This is just rearranging a bit. And so a will be equal to 3. So we know that the first term of our sequence, which has a common difference of 7 and a fifth term of 31, we know that for that sequence, our first term will be 3. Now, if you want to check this, it's fine. We can start by saying, well, 31 will be our fifth value. So if we subtract 7, the previous value will be equal to 24. Remember, there's always a jump of plus 7, so now we're going backwards. 24 minus 7 would be equal to 17. So that would be our third term, because this is term 5, this is term 4, this is term 3. Then we would have 10 as our term 2. And if we subtract 7 again, we've got that our term 1 is equal to 3, which is what we just calculated in here. Okay, so now we'll take a look at exercise 3. Now this is also a very common exercise they can ask you at the beginning of the chapter. It might seem a bit tricky at the beginning, but it's not that difficult, and you'll see now why. So what they ask you is, the fourth term of a sequence is 3. So, okay, we know that u4 will be equal to 3. And the seventh is minus 6. So u7, the seventh term, will be equal to minus 6. So that's fine. So, but now they ask us to find the first term. So find the first term and the common difference. And well, we've got two unknown values. So it might be a bit scary in the beginning because we don't know a. And they are also asking us to calculate d, which we also don't know. So how can we do this? Well, it turns out it's not that difficult. If we think of the equation, un equals a plus n minus 1d. So I'll just write it down so that you can refer to it whenever you need it. It turns out that, well, we can write this as two simultaneous equations. How? Well, we know that u4, so the fourth term, equals 3. I'm just using this equation. You will see how. I'm just using this formula. So 3 is equal to a, which we don't know, so that's an unknown value, plus n minus 1. Now, n minus 1, again, we're looking at this equation. N minus 1 will be equal to 4 minus 1, because n is the position of our term, and since it's the fourth term, the position is the fourth. So it's 4 minus 1, times the common difference, which we don't know. Now, if we just simplify this, we'll get that 3 equals a plus 3d. Okay, so this is our first equation. Now, our second equation will be with this seventh term. So we know that u7, which is equal to minus 6, equals a, we don't know a, plus n minus 1, so 7 minus 1, because it's the seventh term, seventh position equals 7 minus 1, and so we know that minus 6 equals a plus 6d. Oh, sorry, don't know what just happened here. Plus 6d. Great. So now we've got two equations, and we've got these two unknown values, a and d. Now, from here, we can isolate a. So a will be equal to 3 minus 3d. This is just some basic rearranging. And so we get this. And from the second equation, we can get that a equals minus 6 minus 6d. Some rearranging. And now, since both of these values equal a, it means that 3 minus 3d will equal minus 6 minus 6d. Again, we continue with this, we rearrange this, and we get that 3d equals to minus 9, and so d equals to minus 3, or minus 9 over 3, and so this is equal to minus 3, which again is equal to d. So we found d, but now we have to find a. Well, if we take again this equation, so we know that our common difference will be equal to minus 3. But now, if we want to find the first term of our sequence, we know d, so we can just substitute that into that equation, and we get that a equals 3 minus 3d, and so minus 3 times minus 3, because we just calculated d, which is also minus 3. And so we get that this is equal to 3 plus 9, and this will be equal to 12, which will be equal to a. And we just calculated the first term of our sequence and the common difference of our sequence. Okay, so now we completed exercise 3. It's not as difficult as it initially seemed. I hope you found it a bit easier. And now we'll go to exercise 4. Now, exercise 4 says it gives you 3 different terms. So this might be the first term of the sequence. This is the second term. This is the third term. And it continues. And so they ask us to find the nth term. Now, what does the nth term mean? Well, that simply means that n, that our u something, which sometimes is u2, u3, so we don't have a specific position for the term. So that will be simply called un. So mainly what we've got in our equation. Now, this means that in order to find the nth term, we will need to calculate a plus n minus 1. We won't touch this because this is just like a general equation for that sequence, and then times the common difference. So that we can simply substitute anything in here. So we want to find the nth term, so that if in case we want to say n equals 7, we just have to substitute these two values in it. But we obviously have to find a, and we have to find d. Well, a is not that difficult to find, because a is our first term, and our first term equals a plus 5. So we know this because this is the second, this is the third term, so we can actually write this in this other way. So un will equal to a plus 5 plus n minus 1. Again, we don't know n, so we will leave it like this, times d. Now we have to find d. Well, what's d actually? What's the jump in between these two values? Well, if you pay close attention to it, you will see how we're always adding 4. We have our first term, which is a plus 5. We add 4 and we get a plus 9. And so it continues. From a plus 9 to a plus 13, we just have to add 4. So forget about these a's. They are just trying to confuse us, but they are not playing any significant role. So they are just a constant, they are just staying there. So we are really only caring about these values, which are the ones changing, and they are changing +4 every single jump. And so we know that our common difference will be equal to 4, because that's really what changes from every jump. And so we know that un equals un equals a, which again is a plus 5. So that's our first term, right? This is what we found. It's this term in here. So a plus 5 plus, also I didn't mention this, but forget about the fact that these two are the same. This means first term, and this is just, this a means is only a constant, right? Just so that it might confuse you a bit, but it's easier. It's not that difficult. So a plus 5, and now plus n minus 1 times the common difference, which is 4. We just saw that there's always a jump of 4 in between different terms in the sequence. And so un will be equal to a plus 5. We just have to simplify this, plus 4n minus 4, which again, if we simplify this, we'll get that un equals a plus 4n plus 1. And this will be the final result for the nth term. Now, in case we want to find, as mentioned before, in case we want to find the fifth term, we will simply need to substitute the n times 4, 5. So we will need to substitute that for what we have as n. But again, this is the nth term, so if in case they ask you to find the nth term, it's just the general formula, but with this value solved. As you have seen, it's not that difficult. These 4 exercises were quite simple. In a future video, we'll probably cover some of the more complex exercises in relation to arithmetic sequences. If you like the video, don't forget to like the video, subscribe to the channel, and in case you've got any questions, leave them in a comment below, and we'll be more than happy to answer it to you. Also, a quick reminder, our channel, IBLE Math, is an open channel, so in case you have any video that you would like to share, you just have to send it to our email, which we will give you in the description. We'll review it, and in case it's appropriate and it's good enough, we'll post it in our channel with your credits. Thank you for watching, hope this was useful, and see you in the next video.